very quickly we'll find ourselves writing code that we want to have happen multiple times. Whether that's grabbing every paragraph in a page so we can change the background color of it, hiding everything in a menuing system, we'll realize there's code we want repeated. Well, rather than write it out multiple times, I'd rather write it once and be able to say, repeat this 5 times, or repeat this 5,000 times, or just keep on repeating till I tell you otherwise. Perhaps go through every single form field on a web page, or process every link on a web page in some way. And this is what we do when we're creating loops. And you'll also hear this referred to as iteration. Now, the main issue with any loop is not when to loop. Looping's easy. It's when to stop. If we need to loop 200 times, who's keeping track? If we need to loop until we're told to stop, where's the code to figure out how to stop? But let's first figure out the most basic kind of loop. Well, we've seen if statements before. And this is all I have here. If this condition is true in the parentheses, we will execute the code inside the curly braces. Now, if all I do here is replace the if with the word while, we have a loop. There could be 1 line in this code block. There could be 100 lines in this code block. Whatever's in the block gets done every time the loop goes around. So we start to run this code. We'll create a variable called a, set it equal to 1. We'll come down to this while part. I'll check the condition, which in this case is a less than 10. Yes, that's true. I'll jump into the body of the block, execute any lines of code that are there. We'll hit the end, we'll hit the closing brace, and that will jump us back up to the while statement again, where we'll ask the same question. Is a less than 10? Well, yes, it is. It's still 1, in which case we'll continue on processing. What we've done here is create a loop. We've actually created an infinite loop, which isn't all that pleasant. It's a bad thing. This would never end. A is always going to be less than 10 because we never change it. So a very common thing that we need to do in most loops is make sure that whatever we're doing to keep track of the loop is being incremented. So this time I've got an a++ at the end of the body of the loop. So with the iteration in place, we'll start to increment a every time we go around the loop, and we'll keep on going. And at some point, what's going to happen is a will be incremented to 10. We'll come back to the while. This will evaluate as false, and then what we'll just do is we'll jump out of the loop. We'll jump right to the end, and we'll continue processing whatever code happens afterwards. Now there's a variant of the while loop called the do while loop. What this does is keeps the same basic format, but we actually move the condition to the end. So instead of while a is less than 10 being at the start of the block, it's actually at the end of the block. And because of that, we actually need a semicolon at the end of the do while. And the big difference with this is if you have a do while, the block will always be executed at least once. Even if we started off by setting the variable a equal to 100, and our condition here is asking while a is less than 10, we are going to execute the do block once before we even check the condition. So it will always happen at least once. To let you know, while loops are much more common than these do while loop. In the code I've written over the years, I'd guess that I'd write at least 100 whiles for every do. In most loops, it's expected to check the condition before entering the loop, and it's more readable that way too. Now in many loops, a pattern emerges. If I look at a while loop here, I could have a lot of stuff going on in this loop, but I always have to have several pieces in place regardless of what I'm doing. For a start, I need to have something that keeps track of where I am in the loop. So very typically before we hit the while loop, we'll create an index variable or a counter variable. In this case, we'll call it I. I is a very common name for an index. So we set up the index or the counter. We then have to have a place that checks the condition. How do we know whether to keep going through the loop or not? And then in most cases, we have to increment the index at the end. So regardless of what we're doing, we need these 3 pieces in place. Set up the index, check the condition, increment the index. And this is so common that there's even a shorthand way of doing this, a thing that brings all these together, the for loop. With this, you actually bring those 3 pieces together inside the parentheses. They're all there at the top. So regardless of what's in your loop, again, it doesn't really matter. Whatever's between the braces will be executed, whether it's simple or complex. But the loop itself has 3 pieces. We set up the index. So in this case, var I equal to 1. Then there's a semicolon. Then we check the condition, I is less than 10. And then, even though it's right at the top, this is the incrementer. This happens at the end of every loop. And we don't have to go up by 1. You could go up by 4 or 17 or 150 every time if you wanted. So this is very readable because everything about the loop is right there at the top. You don't have to look outside the loop for the index, nor scan inside the loop for the increment. So the for loop is a very common way of doing this. Now next up is a couple of words you'll occasionally run into. Not as much as the whiles and the fors, but it's worthwhile knowing about them. The word called break. Break is a word that will jump us out of the loop. So let's say we start running our code and we hit this loop. We hit it for the first time through. We set up the index equal to 1. We run the check. Is that less than 5,000? Yes, it is. We start to move through the code. We'll hit this if statement, for example, and it'll say, is I equal to 101? No, it isn't. So we'll skip past that code block and continue on, hit the end of the loop, go back up, check the condition again. Yes, I is still less than 5,000. Continue on. Now, at some point, what's going to happen is I will be 101. We'll hit break. As soon as we hit break, we're basically manually saying we're done. We jump completely out of the loop and we continue on, regardless of what the condition was at the top, regardless of where our counter was. If we say break, we're done with the loop. And continue is along the same lines, but not quite as drastic. Let's say in this loop, however I've got it set up, I've got some pieces of code. We're doing some stuff. We're checking some options. We're doing a second set of stuff. Well, as we move through the code, if I check this if statement and my counter divided by 5 leaves a remainder of 0, I'd hit that continue. But if it isn't, I'll just jump straight ahead and keep going on the second part of the loop. Now, at some point, again, we'll jump back. We'll check it. We'll start processing, but if ever at any point I actually hit the word continue, that doesn't mean jump out of the loop. It means jump back up and check the condition again. Don't continue any further with this iteration, just this one. We're not done with the entire loop, but we're done with this time around. So we jump right back up, check the condition again, and then start to process. So continue moves us back up to the top. Break moves us out beyond the bottom of the loop. Now, you won't need continue or break in most loops, but you will see them from time to time, and you need to know what they mean.